Hi all. So in today's section, we are going to learn how to do Gram-Smith process. So you want to know why we are using this Gram-Smith process. So the introduction is, in many applications of linear algebra, we actually work with linearly independent vectors, right? So when we are getting any vectors, okay, so think that we are getting v1, v2, v3. So if it is orthogonal or orthonormal, it is easy to understand. Okay, so it is easy to use the vectors. So if we get any vectors, we can convert that to a orthogonal or orthonormal vectors by using many processes. There are many methods to convert. So in this module, we are mainly concentrating on Gram-Smith process. So by using Gram-Smith process, we can convert the vectors, any type of vectors, into a orthogonal or orthonormal vectors. Okay, so however, orthogonal or orthonormal vectors are easier to work with because inner products become simple, projections are easy to compute, numerical errors are reduced. So these are the benefits of converting some vectors to a orthogonal or orthonormal vectors. So the Gram-Smith process is a systematic method used to convert a linearly independent set of vectors into an orthogonal or orthonormal set that spans the same subspace. Okay, so this is the procedures to do the Gram-Smith method. So what are the objective of Gram method? So it is, so a linearly independent set is given. So think that a set of v1, v2 up to vn, a set of vectors is given. So by using the Gram-Smith process, we convert that to a orthogonal set. Okay, so we represent the orthogonal set with the letter u1, u2 up to un. So just understand that if we get v1, v2, v3, we are converting it to orthogonal set, and we are denoting the orthogonal vectors with the letter u1, u2 up to un, and next we can convert that to orthonormal set also. So by converting that, we are denoting the orthonormal set with the letter e1, e2 up to en. So the steps to do Gram-Smith is, we want to study a formula that I have written in the screen. So the first one is, when we are getting v1, v2 up to vn linearly independent vectors. So the first vector is, first u1 is actually, first orthogonal vector is actually the same v1 itself. So the first orthogonal vector is u1 equal to v1. And for finding the vectors from second onwards, okay, for finding u2, u3 up to un, we actually use the equation given, that is uk. K should be greater than or equal to 2. So think that if I want to find u2, u2 is actually v2 minus summation j is equal to 2 minus 1, that is j equal to 1 itself. So projection, so hope you know the equation of projection vector. So projection vector u1 of v2. So that is the equation to find the u2, u1, u3. And after getting, so you know the projection equation, so it is already written there. So the third step is to, if you want to find the orthonormal set, just simply divide it with the norm of the same u1, u2, u3. So that is the step. It is very easy. If you know the equation of projection vector, it is very easy to find. So just recall the equation of projection vector which we have discussed in the last section. So here I have a problem. I have an example on that. So you have given v1, v2, v3. So we want to convert these vectors to orthogonal or orthonormal vector. So the first one, so here I have just shortened the steps. So the first one is u1 equal to v1, right? So I am writing u1 equal to 1. So u1 is 1, 1, 0 itself. Okay. So the second one is, second orthogonal is actually, so here last I have written the equation is actually u2 equal to, so I am using the equation. By using the equation, you will get u2 equal to v2 minus projection vector of u1 of v2. Okay, so you want to find the projection vector of u1 of v2. So for finding the projection vector of u1 v2, you can use the equation of projection. So for that, you have to find v2 u1, right? So in the product v2 u1 is actually 1. In the product of u1 is actually 2. So the projection vector you will get 1 by 2 into 1 1 0, that is 1 by 2 1 by 2 0. So if you minus v2 with this projection vector, you will get the u2. Okay, similarly in the similar manner itself, so here you have u3 also. So u3 you can find in the similar way by using the equation. So the equation, by using the equation, you will get like this: projection u1 of v3 minus projection u2 of v3. So in the similar way, you can find the projection vector of this. So here I have the steps written here. So you can find the projection vector of each vector, and if you minus that with this, you will get u3 as minus 2 by 3, 2 by 3 and 2 by 3. So here the thing you want to understand is this is actually orthogonal set. Okay, u1, u2, u3 is actually orthogonal set. So for finding orthonormal, and I will just say that how to find that. So for finding orthonormal set, just divide each set with its norm. Okay, norm is, you know the equation of norm, right? Norm u1, and we have discussed that in the last session. Just recall that. So u1 divided by norm of u1, you will get e1, and u2 divided by norm of u2, you will get e2, and u3 divided by norm of u3, you will get e3. So like that you can find the orthonormal set also. So here is just one problem I have discussed. You can get many problems. We will do that as assignments. Okay, so just understand how the process goes. So the main important thing you have to understand is this process is used to convert linearly independent vectors to orthogonal vectors or orthonormal vectors. So you want to study the equation, that is important. This equation is important. The equation of projection vector is important. So you have to study this. Okay, so hope you understand the section.